Hello everyone, welcome to physics. We are still doing magnetism, and this is the last lesson in magnetism. So this is how we have been moving. We started introducing this topic. After that, we looked at terminologies, methods of magnetization, which is stroking method, electrical method, induction method, hammering method, and we went as far as methods of demagnetization. So here we are going to finish with domain theory, and also known as magnetism theory. Domain theory, or known as magnetism theory. Now let us start looking at theory of magnetism, or also known as domain theory. So theory of magnetism states that inside the magnet there are small regions in which magnetic direction of all dipoles are aligned in the same direction. Inside the magnet there are small regions in which magnetic directions of all dipoles are aligned in the same direction. So as I've already said in previous slides, I said that inside the magnet there are these small regions known as domains. So these domains, they are aligned in the same direction if the material is magnetized. So if material is magnetized, these small regions, they are aligned in the same direction. For unmagnetized material, these small regions, they point in different directions. So this is how theory of magnetism states like. Now let us show if it is really true that inside the magnet there are these small regions known as domains, or known as molecular magnets. So this is how we can show the existence of molecular magnets. So the first one is saying a magnetized steel bar is cut in two halves and tested for polarity. So you take the magnetized steel bar and you cut it into halves, and then you test for polarity. So you see that the halves which have been cut, they show that they are magnets with both north and south pole on each half. So this shows that there is really molecular magnets or small regions inside the magnet. Now try also to cut the halves. Try to cut the half in two halves, and again test for polarity. In the half which you have cut, try to cut it into equal halves and test for polarity. You also see that the half of halves, they are also magnets with both north and south pole. Now continue cutting the halves until one is not able to cut anymore. Continue cutting the halves until one is not able to cut anymore. So, and again test for polarity. So you see that the small cuts, if you test for polarity, you see that they are also magnets with north and south pole. So each piece of magnet is made up of lots of tiny magnets, or lots of these domains. So all align with their north poles pointing in the same direction. So the small halves which have been cut, inside those small halves, you see there are lots of tiny magnets all lined up with their north poles pointing in the same direction, showing that they are really magnets. Now let me show you the existence of molecular magnets diagrammatically, so that we can be together. As I've already said, a magnetized steel bar is cut into halves and tested for polarity. So after testing for polarity, you see that these halves, they are now also magnets. So they are now also magnets with a north and south pole. So here is our magnetized steel bar. So let us cut this magnetized steel bar into halves. So after cutting the magnetized steel bar, you see that these halves, they are also magnets. So with north and south pole. So after testing for polarity, you also see that these halves, they are also magnets. So with north and south pole, as I've already said. Now you can also continue cutting these halves until one is not able to cut anymore. So you continue to cut these halves. You, after testing for polarity, you also see that these halves, they are also magnets with north and south poles. So you are continuing cutting these halves into smaller halves, so that one is not able to cut any more. After testing for polarity, you also see that these small halves, they are also magnets with north and south pole. So this really shows that inside the magnet there are small tiny magnets, or there are small molecular magnets, or there are small domains. So each piece of magnet is made up of lots of tiny magnets, all aligned up with their north poles pointing in the same direction. So this has shown us that each piece of magnet is made up of lots of these tiny magnets, or they're made up of these molecular magnets, or they're made up of these domains, all aligned up in the aligned up with their north poles pointing in the same direction. So we have shown you how we have shown you the existence of molecular magnets, or these tiny magnets, or these domains. Now let us see how domain theory, or theory of magnetism, can help us to explain the process of magnetism and process of magnetization. Now let us start with magnetization. So we already defined magnetization as the process of making magnet from magnetic materials such as iron or steel. Now let us see how domain theory can help us to explain the fully magnetized material. So a fully magnetized material, this is when a ferromagnetic material which is said to be magnetically saturated. So a ferromagnetic material is said to be magnetically saturated. But not only that, is when all molecular magnets or domains point in the same direction. So when a thing is fully magnetized, when the material is fully magnetized, you see that all these molecular magnets, they point in the same direction. Now this is our magnet with north and south pole. So you see in the middle there are these small molecular magnets. These molecular magnets, or tiny magnets, pointing towards northern direction, or they point in the same direction, but direction of the north. So you see all those arrows, they are pointing in the north direction, in the same direction. But mind you, in the poles, north and the south poles, you see those arrows, they are still pointing to the north direction, but you see they have deflected a little bit. So this deflection comes in because these small molecular magnets, they tend to repel. There is that repulsion. They tend to repel, so they go they deflect towards that that north pole. So this can be shown when you take a magnet and you bring your nails close to the magnet. You see that the nails will not stand straight. The nails will deflect. So there is that repulsion. That's why you see those arrows in the inside the magnet. They also get repelled, or they also repel. So this is how the domain theory can help us to explain the magnetization. So the fully magnetized material is when those molecular magnets point in the same direction, as you have already seen in the diagram. Now let us still continue how domain theory can help us to explain magnetization and demagnetization. So remember, we are still on magnetization, how magnetization can be explained using domain theory. Now let us start looking at the second class of magnetization, which is partially magnetized material. So in partially magnetized material, domains are not all aligned in the same direction. So you see some domains aligned in the same direction, but other domains also aligned in different directions with the other domains. So here is here is inside our magnet. You see some domains, they are aligned in the same direction towards the north, but some domains, they are aligned in different directions. So when the object is like that, or when the material is like that, we call it that material is partially magnetized. So remember, the domains are not all aligned in the same direction. Now let us move to the third class of magnetization, on how domain theory can help us to explain magnetization. Now this class is the class of unmagnetized material. The class of unmagnetized material. Remember, we are still on magnetization, on how domain theory can help us to explain magnetization. So let us look at this third class of magnetization, which is unmagnetized material. So in an unmagnetized material, tiny magnets, or these domains, or these small regions known as molecular magnets, they point in all directions. In other words, they point in different directions, not in the same directions. But you see all the molecular magnets pointing to the to all directions, or in different directions. So this is our magnet. You see each and every molecular magnet pointing in a different direction, in all directions. So when you see the material like this, just know that material is unmagnetized material. But mind you, the north pole of one domain is being neutralized by the south pole of the another. So keep following arrows. You see that the first arrow, the north of that first arrow is being neutralized by the south of the another pole. Look inside that magnetic material, and you see that each domain is the north pole of the domain is being neutralized by the south pole of another. So for that, you see that the magnetic effects cancel out, and there is no poles nearby. Then when you test for polarity, you see that your object is not it's not magnetized. So this comes in because the north pole of one domain is being neutralized by the south pole of the another domain, so making the magnetic effects to cancel out and resulting to no poles nearby. Now let us finish this topic by looking at domain theory, helping us to explain the magnetization and the demagnetization. So in previous slides we have already explained how this domain theory can help us to explain the magnetization. But now let us see how this domain theory can help us to explain demagnetization by starting with self-demagnetization. So self-demagnetization is when the walls of domains slowly return to their original state, as this is the most stable state. So self-demagnetization, you see these domains or these small molecules or these tiny magnets slowly returning to their original state for them to become more stable. So after these domains are returning to their original state, in order to attain the stability, is when you see your magnet demagnetizing. So this comes in due to the poles at the end, which tend to reverse the direction of molecular magnets. So the returning of these domains to their original state comes in due to poles found at the end tend to reverse the direction of the molecular magnets. So by doing that, you see that the domains are returning and making your material losing its magnetism. So let us see how demagnetization as a whole can be explained using domain theory. So in this demagnetization process, the process of demagnetization process mostly is influenced by the external forces. So the external forces are the ones which makes the magnetized material to lose its magnetism. So these external forces provide the molecular magnets with enough energy to overcome the forces holding them inside that magnet in a particular direction. So the external forces makes these molecular magnets to gain more energy to overcome the forces which is within, the forces which has aligned the forces which have aligned the domains. So the external source supply energy to molecular magnets to overcome the forces which have aligned them. So the question going to be where do this energy comes from? So as I've already said, this energy comes from external sources. So for example, when you are heating your magnet, you are providing the molecular magnets with enough energy to overcome the forces that hold them in a particular direction. So heating them, you provide energy to the molecular magnets. Hammering, you also provide the energy to the molecular magnets. And even dropping the magnet hard on the dropping the magnet repeatedly on the hard surface, you also providing energy to the molecular magnets, able to overcome forces which hold them in a particular direction, the direction of the north. And even passing the alternate current on the magnet, you also help to provide energy to molecular magnets. So this marks the end of the topic of magnetism. So in the next class we are going to discuss our new topic. Please don't miss the next topic. Thank you.